Hi, this is Ms. Fizone, and we are factoring polynomials. Uh-oh, what's happening? Oh, it is working. Never mind. Okay, so we're going to take finding the roots of problems we can't factor, and we're actually going to graph them now. Okay, so we're not doing anything new today. We're taking those two lessons, those two topics that we've been working on, and putting them together. So we're going to find the roots, extrema, behavior, intervals of increasing and decreasing, and graphing. All right, so let's start with x cubed plus 3x squared minus 13x minus 15. Again, first thing you do, see if you can factor it. Again, I'm having you practice things that cannot be factored. So x cubed plus 3x squared minus 13x minus 15. So what's the first thing you do if you can't factor? Write down, we need to find the roots. To find the roots, we need the possible roots. What are the possible roots for negative 15? Plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 5, 15. And that's it. Okay? So we're going to do synthetic division. We have 8 options. Okay? So let's do it. 1, 3, negative 13, negative 15. I like to start with 1. You don't have to, but I like starting with 1, working my way up. All right, so let's bring the 1 down. 1, 4, 4, negative 9, negative 9. So that's a no. Sadness. So cross off the 1. Now do the same thing with negative 1. 1, 3, negative 13, negative 15. Let's try it. Bring the 1 down. Negative 1, 2. Negative 2, negative 15. Oh, hey, this one worked. That's exciting. Yay. So we get x plus 1, and then what are we left with? X squared plus 2x minus 15. All right, so now we're left with something. Can we factor that? Can we do an MC chart? Does it work? Negative 15 combined to 2. 5 times 3? Oh, hey, that factors. That's exciting. Which one's negative? The 3. So this is actually a completely factorable problem. X plus 5, x minus 3. So this is my p of x. Right? That's my p of x. I factored it. Right? Is that so terrible now? No. So let's start with the roots. What are the roots? X equals negative 1. X equals negative 5, and x equals 3. Not so terrible. Just switch our signs. Okay? So I switch the signs. Negative 1, negative 5, 3. I'm going to write this here. X equals 3. X equals negative 5. X equals negative 1. Okay. All right, so now extrema. How do we find extrema? I like plotting it first. It makes it a little easier. So I'm going to draw my graph so I can kind of see the ones that are next to each other. Okay. So we have to go up to 3. 1, 2, 3. And left to 5. 1, 2, 3, 4, 5. And then negative 1. So I need midpoints, right? What's the halfway point between negative 1 and 3? So negative 1 plus 3 divided by 2. That's 2 divided by 2 equals 1. Right? And do the same thing for these two. We have negative 1 and negative 5, the two next to each other. Negative 1 plus negative 5 divided by 2. Negative 6 over 2 is negative 3. So my 2 points of extrema, the x values are 1 and negative 3. 1 and negative 3. Doing just what we did last time. Okay. So I have 1 and negative 3. Now how do you find the y values? Plug in. You can plug into the original. Oops, I'm on the wrong one. Plug into the original or plug into the factor. It doesn't matter. Right. So I'm going to plug into the original. So I'm going to replace my original problem with 1. So 1, helps if my calculator's on. 1 to the third. Can you see what I'm doing? Nope. 1 to the third plus 4 times 1 squared minus 13 times 1 plus 2. Enter. Negative 6. So you get 1, negative 6. Same thing. Instead of 1, I'm going to replace all my x's with negative 3. Parentheses, negative 3 to the third plus 4 times negative 3 minus 13 times negative 3 plus 2. 2. Wow, these numbers are nice. Cool. So now I'm going to go to my graph and plot those. So I've got 1, negative 6. Please pay attention. It's so frustrating on tests when you guys get the right numbers and then you plot them wrong. Guys, 1 comma negative 6. So on my graph, 1, negative 6 is down here. Negative 3 comma 2. 3, 2. Left 3, up 2. Pretty much I'm done, pretty much. Look, connect the dot. It's like connecting the dots, guys. So where should this arrow? It's going to keep going up. That's what makes sense. Keep going down. I have no double roots. I have nothing weird happening. That's it. That's your graph. You graphed it. So now what is the behavior? What's my behavior? As x goes to infinity, what happened? As x is positive, what's happening in the y? It's going up. Y is going to infinity. X goes to negative infinity. What's happening to the y? This way. Negative infinity. Done. Last thing is increasing, decreasing. Where is this thing increasing? Remember, where is the man walking uphill? Where is the man walking uphill? Left to right. He's going up, then he goes down, then he goes up again. The yellow is where he's increasing. Okay? So the arrow means negative infinity. Negative infinity. And then where's the yellow stop? Negative 3. Do not put the y values. I don't know how else to say that. X value